It covers alcohols and then alkenes, okay? So this one was at the very beginning. Okay, so you have this handout, okay? So,
I got this.
we
How
got it.
detailed do you want this answer?
So I'm just, provide the organic products or reactants for each of the following reactions with stereochemistry, if any.
Okay,
So alcohol,
it'd be the same general shape, but instead of the OH, it would be dashed wedge to the back, bromine. Right,
okay, good.
Yes.
and that would be,
So you're not, if I have this structure, you're just touching this one, right? And then you retain this, okay?
is that SN2?
Yeah, okay, so it's gonna be to the back, okay? So now there is so I'm not asking for the mechanism, just obviously if you know the mechanism, it helps you, right? So now this one, you have a nucleophile. So you're gonna have, so next, Tyler. Nucleophile, take out the BR,
And you tag it from the back,
or
like flip it?
front, because this is to the back,
Oh,
Okay.
okay.
so just draw the other substituents, and this one now inverts. Okay? So nucleophile, the CN, so NaCN, this is a plus, minus, so don't attach the sodium because that will not, that is not a nucleophile. Okay? So what if it's like this, NaSCH3,
Same thing,
same thing except it's a
SCH3.
SH3, okay? So now this one, second one, so let's go around. Your turn, Brayden.
Oh, no.
You got this.
So here, Cl, so the question mark is the reagent. Okay, what are you gonna add? And I have a glue, SO2HCl. So obviously you're gonna have, so the O came out, right?
Uh-huh.
So in the reactant, there's a Cl and there's an S.
Uh-huh. Well, so if,
So there's an S, okay? And there's a Cl that came out and there's an H that came out. So the H is coming from here and then the O, obviously, so if you're looking from here to here, the OH came out and the Cl went in. And there's an S that came out. So if you go backwards, there's
Well,
an,
Since it's O2, is there also an O in the?
correct,
reactant?
okay? And what else?
If a Cl also came out and there's one in the product, is there a Cl? Or is it Cl2?
Yeah, okay. All right. So now what is in here? So from here to here, the S is the reactant and then the Cl came out. So,
So is it just SCH3? in the
okay,
react-
but this is a negative, right? So SH3 completed.
is the SCH3 a negative, or is,
Negative, you can write negative or the same as this one,
so then it would be
Na.
Na?
Yeah, okay. If you just write S negative, SH3, then it's okay.
Okay.
So now this one. Next, who wants to take this question?
Of course, Jessica left. What a great time for Jessica to leave.
Amy, you wanna take this?
Oh, okay, it's alcohol, it's a ring.
It's the alcohol chapter.
Yep, it's a ring.
So I put together step 1 and step 2, okay?
Mhm.
So this one is kind of similar to this,
Okay. So
but
you're gonna take that, CL instead of the OH? No?
so this one takes in the H, so maybe one way to think about it is the H and the Cl will combine,
To make hydrochloric acid.
okay? But that's the first step. So it kind of combined this and that one, similar, right? So the H and the Cl combines, therefore the TS goes in here.
Oh, TS.
Replaces the H,
Okay.
okay? Then there's another attack of there's an attack of the nucleophile. So when you take out the H, you put TS, this one did not change,
Mm-hmm.
okay?
And then it's going to TS.
The TS is gonna, TS is like BR,
Okay.
okay? Then this is the nucleophile,
Mm-hmm.
okay?
So it's the N plus my, okay.
So nucleophile like this, it inverts.
So it'll be
So do the same thing, right?
CN, it'll be the chair structure.
Okay? And then you're just gonna copy this.
Right, and that's
Don't invert, okay?
still going the same
Sorry,
way.
let me,
Yeah, nothing has changed except for that, and then
Correct.
it's, it was, what, equatorial, and then it would be axial.
Yeah. okay? Oh, CN, sorry.
Yeah, CN.
Okay. So if it were chair, this one, the way you write the opposite one, if it's axial, it's gonna be equatorial. Get that? If this were
Mm-hmm.
like this structure, so the opposite instead of to the back, it's gonna be axial, and the opposite is equatorial. Get that? So, for example, I do the same, right, here. Okay, so you're gonna write. Okay, so just write it like that. The same, okay? And this one is going to be, if opposite, it's down.
Down
Okay.
instead of out.
Oh, no, BR. BR. And then, so if you do this step, you're
Then
gonna
it'll
have the
be-
same configuration as
And then
this.
it'll be CN, but then
Correct.
it'll go back the other way.
Okay? So if it's flat like this, you have the wedge
Mm-hmm.
or dashed wedge, but if it's drawn this way, it's gonna be, the opposite is gonna be going down, right? So you're attacking it here, and then you're attacking it here.
Are you gonna ask us something like that, but have us write out all the little itty bitty steps to it, like show you where the electrons go?
No.
No. Just like that.
For this question,
Yeah, but
yes.
like on the exam, is there gonna be one with that complex, that many steps?
Just 2 steps.
A lot of thinking, no?
Despite all those things in there, we just have the same thing, same products.
Okay. Okay. Alright, I'm just overthinking it.
Part C, why is it going down instead of in the same direction?
Okay, so
like
because
in A?
this one, so remember the OH cannot leave as OH minus because it's basic, so you don't want, it's not a good leaving group. So you have to make it a good leaving group by putting TS. Or you change it into this step, okay? So different ways to make the OH come out, all right, is to convert this H to TS, then that becomes a good leaving group, okay?
Yeah, but then when it leaves, it doesn't change the configuration.
It will change. So, okay, so the first step is like this. Okay? To get that, that's the first step.
Mm-hmm.
Then the second step is a nucleophile, so the CN negative attacks this side. Okay?
Yeah. I get it. So since you didn't remove the O, you don't change it from going up to going
Correct.
down.
Correct. So now this one, so okay. So basically it's kind of similar to that one, right? I'm sorry. Similar to this one.
You're trying to figure out what the question was asking?
Yeah, because I'm reading and I'm
Yeah,
talking,
you're
sorry.
like,
Okay. I thought I made a mistake, but it's okay.
oops.
Alright. So now
Hmm.
I inverted this one, right?
Mm-hmm. So there were 2 steps.
So the first step, you have to take the OH away, and the second step is putting it back?
Yep.
Oh, so are you just gonna make it into an alkene, and then you're just gonna make it back into an alcohol? No, because then why would it invert? Because there would be.
So I just went over it.
But that's not the same, oh, sure.
I went over it. But the second step is different.
Yeah, because
Oh,
you
cause
have
then we keep the O.
H2O or
Sorry, the first one be
The first-
TSCL.
Correct.
Paired pyridine,
TSCL.
and
And then what is the next step?
So you won't be thinking that.
it would be DMSO
And
and
instead of CN, what did I put?
OH.
OH. So now NaOH.
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 Oh, like in that one? I thought that'd be much harder.
Oh, wait, something makes sense.
Oh,
Yeah,
MF.
something has to take this.
DMF or DMSO?
No, and make
Oh,
it
D, it looked like an O.
Oh, I'm sorry.
I'm like, oh, I'm at.
DMSO.
Oh my
We were
god.
on the same
What
page.
made it? I looked at that.
Okay, so this one. How about this one? Who wants to take this question? We did this already. Texas?
It's.
Okay.
Get rid of the double bonds. Yay.
I'm gonna give this question.
Oh, I already had that one written down.
Yeah, right?
Oh.
Said that it was already done, that's what I said.
Are you gonna have us write down?
How
I
about,
didn't realize I had it written down already.
If you ask for the stereochemistry, for that one, do you want us to, because the first one's E, there are a bunch of E stereochemistry. Is that stereochemistry, does that fall underneath stereochemistry?
once you hydrogenate it, there's no more no more, nothing, disappeared.
Okay, so we're good, got it.
You just have a bunch of
Yeah.
hydrogens.
When we draw the new structure, do we have to name it as well in the exam?
No,
Okay.
I'm not asking. There's a nomenclature page.
Okay.
Okay.
But this one, no, you don't have to name. I said, just follow the instruction, provide organic parts, it's gonna be like that. The
Okay.
format is the same. Okay? So now how about this one? So it's now alkene. It's now alkene. The alkenes, what happens when you put hydrochloric acid? So remember the general mechanism for the alkenes would be, for the alcohol, we are substituting, right? And then there's also addition. So you're just adding.
Oh,
You're
is
just
this before we
moving-
add the H on one side and CL on the other?
So I said there are two products, two
You're
possibilities.
just moving that double bond around?
No,
Moving it to the
addition.
neighbor? Oh,
Addition.
addition? Oh.
What you're adding together. So the double bond, because you're adding a reagent to it, what do you get? You're putting together, it's like a condensation, you add together. So this is a nucleophile, okay?
Oh, yeah.
So what do you get when you add, you put together?
Take that out. You put that with it.
So, sometimes to get to the answer, if you know, okay, it's an addition, and also, okay, is there a nucleophile, electrophile in here? So if you're
That was those rules.
if you're adding on the alkene, okay? So this one is a nucleophile, it's gonna grab what first? Hydrogen. Okay? When it grabs the hydrogen, there's a carbocation ion. Alright? So there's a carbocation ion. So you're gonna add here. Is it like this? Or is it the other way?
The other way.
The other way, right? Because you want the H to be here and the Cl here.
Or substituted.
So when you add it, you get this. I did not write the H anymore because it's, when you add this, it becomes CH3. Okay? All right. So now I have this. So one possibility is the Cl goes in, right? So where would the Cl go? To the plus. Correct. Okay? So I have this. Because you're adding, the number of carbons stay the same, right? It's gonna be Cl over here. But remember, secondary carbocation ion?
Hydride shift.
Correct. How do you get the hydride shift?
You moved the stick.
You move the hydride. Where's the hydride?
On the end. No, it's
On the where?
on the plus side, on the carbocation, you move it towards the tertiary one. So
Correct.
That way.
The H over here.
Yeah.
The neighbor, okay? So the H over here, you interchange the H and the plus, so actually it becomes this. Oh, yeah, correct, right? So therefore, remember, you're gonna add the Cl. So where would the Cl go? On the plus. So the other possibility would be this.
Is there no way for ring expansion?
No,
You got
no.
that?
I will go over that again. I will go over ring expansion in a bit, but let's finish this one, okay? So now, I repeat the question, but I now have water, and then sulfuric acid at the bottom is just a catalyst, okay? So the same idea, you're gonna add, it's hydration, okay? So what is the end product? Alcohol. So the same, you're gonna add HOH. I'm not doing the mechanism, but it's gonna undergo the same intermediate, okay? The same intermediate, the same rearrange, the same hydride shift. So what would the product be? Same, except OH, okay? Right? So how about, so this one only one product, I said only one product, right? One product. So this is still in the alkene chapter, but this one is also hydration, okay? But I did not go over actually the mechanism, but there is like a transition state, all right? So this is hydroboration, oxidation. So does it give you, what will it give? It's the alkene chapter again. hydration, alcohol. But what is the effect? Is it gonna be the same as this one or not? I said only one product.
Dehydrating.
You hydrate, right? So instead of it like this, so H, right? OH. This one is the opposite. The addition of the HOH is
Less, to the less substitute.
correct. So what would it look like?
It would be more answer.
What would it look like? Where is the OH going to be?
At the end.
At the end. Okay, so the number of carbons stay the same. So, in the other, if I have an alkyne, right? And then I do this reaction, what do you get? It's also hydration. This is an alkyne. So this means like this. Alkyne is a triple bond.
An enol?
Yeah,
Oh, yes. Come on it.
okay, so hydration, this is a hydration. So you're gonna add OH where? On the triple bond, but you split, right? It's split, I'm sorry.
In the middle.
You had it like this, right? So that's why I have the OH in here. So now I'm gonna do the same thing, right? So water, HOH, there's a carbon in here, right? HOH. Because I'm not asking for the mechanism, actually I did not go over the mechanism, I'm just gonna move the bonds, okay? So move the bonds. Okay, so this was the enol. The final structure would be, I have to shift, I have to change, right? So this one becomes an aldehyde. So like this, and this grabs the H, and now you have this structure. So the water gets absorbed into the triple bond, so H2O. H2O. Okay? Okay, so any question about that?
I wouldn't even know what to ask.
Right?
Ask me something.
I don't even know.
It's one of those, just memorize it, because, just memorize it.